The second page of section 1.2 in our workbook deals with some more graphing examples. And this time we are given the function and we can input our x values and output our y values. So take a look at example 3, part A. It says sketch the graphs of each function and check with the calculator. So our function rule is f of x equals 3x minus 1, and we are asked to input these 5 numbers. F of negative 2 is equal to 3. I'm going to take this function rule. Everywhere there's an x, plug in a negative 2 minus 1, which is negative 6 minus 1, negative 7. So what we just did here, we said that when you plug in an x value of negative 2, we get a y value of negative 7. Moving on to the next value, x equals negative 1. 3 times negative 1 minus 1 is equal to a negative 4. So that means we have the point negative 1, negative 4. Then x equals 0. 3 times 0 minus 1 is equal to a negative 1. So that function rule tells me when x is 0, y is negative 1. F of 1 is equal to 3 times 1 minus 1, which is 2. So we have the point 1, 2. And then f of 2 is equal to 3 times 2 minus 1, which is positive 5. So the last point we're going to graph is the point 2, 5. So going over here to our graph grid, notice that the scale once again looks like it's at a scale of 1/2. 1/2, 1, 1.5, 2, 2.5. So we don't have room for negative 2, negative 7. So when you have something like that, you can omit that point if you want, or you can take your best guess at where negative 7 would be. It would be way down here. So I'm going to omit negative 2, negative 7 on my graph. It's still there. It's just that my grid that I'm going to graph on is not big enough for me to plot it. So the first point I'm going to plot is negative 1, negative 4. Now I know negative 4 is not on our graph either, but what we're going to do is we're going to estimate where negative 4 could be. So there's negative 1 on the y, negative 2 on the y, negative 3 on the y, and I'm going to say negative 4 is roughly right there. So there's negative 1, negative 4. Then the next point we're going to graph is 0, negative 1. So 0, this one will fit on our grid. X is 0, y is negative 1. There's our second point that I'm graphing. Third point on our table. Moving to the fourth point on our table, 1, 2. When x is 1, so we move along the x-axis to 1, then we move up along that grid line until we get to 2. So 1, 2. There's our next point, 1, 2. And then 2, 5. Once again, the 5 is going to be difficult to graph on this grid because it only goes to 3. But if you wanted to go for it, we could. We would go across to 2 and then up 1, 2, 3, 4, roughly right there. Right there, roughly. That would be the point 2, 5. Now, once you have your points graphed, let me fill in my table very quickly. I omitted that. You're going to connect the points together with a line. And there's our graph that goes with our table, our function rule, and the work that generated it. On part B, we are given a quadratic equation, x squared minus 2x minus 3. It's called quadratic because of the highest power being a square, and it's not divided by any values of x. We have our quadratic equation here, and we just need to generate the points so we can graph. So starting off, we have negative 2, negative 1, 0, 1, and 2, f of negative 2. Everywhere there's an x, I'm going to plug in negative 2. And I'm going to get 4 plus 4 minus 3, which is 5. So at negative 2, we have a y value of negative 5, positive 5. f of -1. Everywhere there's an x, plug in a -1. -1 squared minus 2 times -1 minus 3 is equal to 1 plus 2 minus 3 is equal to 0. So at -1, the y value is 0. F of 0 is equal to 0 squared minus 2 times 0 minus 3. So it's equal to -3. F of 1 is equal to 1 squared minus 2 times 1 minus 3, which is 1 minus 2 minus 3, which is -4. And the last one, I'm going to work it right over here. F of 2 is equal to 2 squared minus 2 times 2 minus 3, which works out to -3. So we have 5 points to graph. A few of them won't fit on this graph paper that we have due to the scale, but working with what we have, -2 to +5, I can't graph that. That 5 is just too high. But -1 to 0, -1, 0, x is -1, y is 0, that's an intercept. So there we are. 0, -3. When x is 0, y is -3. So that's graphed down here. So I graphed this one and I graphed this one. 1, -4. Likewise, I'm just going to have to estimate where the -4 is, roughly right there. And then 2, -3. So 2, and then go down to -3. So on this graph, I know that we're coming in from somewhere up here, -2, 5. We're coming in, and we're going to go down here. We're going to hit this point. We're going to turn, and then go back up. Roughly speaking, there's our graph. Now, on our homework, My Open Math, you do have a few graphing problems. If you run into trouble with this, send me a text or an email or a Blackboard message, and I will see if I can help you with the graphing the points and connecting or creating the graphs that you need for that particular homework problem. All right, moving to our next part of this page in our workbook, we're going to find the domain and range from a graph, which we did also on the first page in the first video of this section. But on this one, notice that it has some red dots. So that means that this function does not go on forever. It is finite in length. And so the domain, you get your domain from moving along the x-axis and then connecting up to the graph. So moving along the x-axis, the first x value that we encounter is right here at -2, that when we extend it up, we intersect our graph. And we intersect it at this red point, which, looking at our scale, is the value of 1, 2, 3, 4, 5. So our graph starts at -2, 5. So we're moving left to right for domain, and we're visually scanning up and down to see if we're still hitting our graph. So as we move to the right, right here, that's where the graph stops, and it matches up to the point 1.5 on the x-axis. So this particular graph stops when x is equal to 1.5, 3 halves, 1.5, and the y value is at 0.5 or 1/2. Now, so we have the graph labeled. It's a continuous graph. We do not have to pick up our pencil if we were tracing this. That means it's a continuous graph. The x values give me the domain from -2 to 1.5, and the y values give me the range. Now, I was about to write down 5 and 0.5, but when I scanned my graph, I stopped for a moment. This is not the lowest point on the y values for our graph. So I'm going to have to do a visual scan from the bottom of the y-axis up to the top of the y-axis. And as I scan up the y-axis, I'm looking left and right to see where my graph is. So coming up from the bottom right here at this y value, I have a part of the graph that is graphing. Now, I'm not quite sure what the x value is, but that's okay because we're looking for range, and range has to do with y values. So scanning up the y value that we have, the graph, starting the graph, the lowest y value that we have, looks like it's right here, and that's at some x value, the y value of -3. And then we keep scanning up the y-axis. We have our starting point for the range. Starting point is -3. We keep scanning up the y-axis, once again visually looking left and right to see where the function stops graphing. And it stops graphing right here. We trace this over. We have a y value of 5. So our domain is from -2 to 1.5, and our range is from -3 to 5. On the next graph, we have a piecewise function where we have a nice quadratic working on the left, and then a linear function and a constant function on the right. Notice the open circles. Open circles mean that that particular point is not included in the graph. So I'm going to do domain first. So I'm going to start scanning from the left, moving across the x-axis. And as I scan from the left, I'm going to go up and down and I'm looking to see where this graph starts. And obviously the graph starts right here. And that is an x value of -5. So doing our domain, it doesn't matter what the y value is. I'm just going to call it y sub 0. Our x value is -5. That's where our function starts. We keep scanning left to right, tracing the function, glancing up and down, and we see that this parabola stops right here. It's got a filled in dot right here, so that means that x equals 0 is included in our domain. Now we do have a jump, but that's okay because we jump with a filled dot up to an open dot, so x equals 0 is included. If you remember, all along the y-axis represents x equals 0. So x equals 0 here, 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 and here. So 0 is included in our domain. Now, I'm not going to write anything else down because we have a function with a domain that starts at -5, gets to x equals 0, and then it just keeps going. It did jump, but it stayed on x equals 0 until that closed dot filled that open dot, and it keeps going along this linear function, and then we get to this point. It's an open circle. I'm going to check down here. There's nowhere with a closed dot that would fill that open circle. So that open circle is a break in our domain. We trace it back to here, and that happened at 3 on the x-axis. So our domain has a break at 3. Now you notice that it just picks itself right back up on the other side of 3 and becomes constant until it gets to x equals 6. So I'm going to join this domain piece, -5 to 3, to x equals 3, to this domain piece, which is from 3 to 6. And the 6 is not included because it's an open dot. If we take a look at the range now, range y values, we're scanning up from the bottom to the top of the y-axis, and I start scanning and the function starts graphing right here, and it just keeps scanning. Now this is where it gets interesting because as I'm scanning, I'm looking left and right. It keeps scanning, going up this y-axis until I get to about right here. There's nothing graphing to the x and y. Nothing is graphing. So that means that from this space on the y-axis to just on the other side of 4 on the y-axis, the range is not existing. So I'm going to start off my range that corresponds to y equals -2, and I scan all the way up to about right here. right there. And that y value is roughly, I'm going to take a guess of 2.5. Best guess I can take because I really can't get in there and see what's happening and close on that grid. So I'm going to estimate 2.5. And that's going to join with some more for the range because we know more of the graph is graphing up there. Now, from roughly 2.5 to 4, the range does not exist, but at 4, on the x and the y, looking at the y-axis here, we have an open circle. So 4 is not included in our y values for our range. So I'm going to put parentheses. I'm going to trace, and then we get up to 6, and you're thinking, okay, now we have another jump, or perhaps you're thinking that. Well, the range is actually filled in at 6, then 7. The range is filled in at y equals 7 because this line fills in those dots for the y-axis. So we're going to pick up to just above the 4, and we're going to graph. And at this point, we think, oh, there might be a break in the range, but no, there's a line. It's filling in that open circle. So the range is going to stop at 7, and 7 is going to be included.